Hi everyone, welcome to lesson 3.3. This lesson is on congruent triangles. So if we remember from previous lessons, the word congruent basically means the same. So we've learned about congruent segments and congruent angles. But we have to say for each shape exactly in what way they can be the same. So congruent segments are having the same length. But length doesn't make sense for angles. Angles don't have a length, they have a measure. So for angles, congruent means having the same measure, not having the same length. For triangles, they don't have a length and they don't really have a measure. They're kind of something else. So we need to come up with a new version of what it means for things to be the same that works for triangles. Okay, so we have kind of a fancy way of saying this and kind of a casual way of saying it. The first way we're going to do it is the fancy way, and it's this. Two triangles are congruent, or the same, if one can be mapped exactly onto the other by translating, rotating, or reflecting. So translating, rotating, and reflecting are ways that we can move shapes around in space. And here's what they look like. A translation is this first one, where I've taken the triangle and I'm just sliding it. So I'm not spinning it or flipping it, I'm just taking it as is and moving it around. That's a translation. A rotation is you spin it. So it's starting with this orientation and now I'm spinning it around this point, so now it's upright. So this is, a rotation. And then a reflection is you flip it. So maybe we flip it side to side. So now we create a mirror image over here. Or maybe we flip it up and down. So we create a mirror image down there. So these are reflections. And we can also do combinations of these. So you might translate and rotate, or you might reflect and rotate and translate. But the main idea here is if you do any one of these, you're going to end up with an exact copy of what you started with. It's just going to be moved. It might be flipped, it might be spun, it might just be moved over there, but it's the exact same shape. So the kind of intuitive or casual way of talking about congruent triangles is that one is an exact copy of the other. So we have an exact copy, but they just might be moved around. Okay, so we can think of congruent triangles as being exact copies. So they're going to have the same angles and the same sides in the same configuration. And that leads us to our next point. So a big thing we're going to talk about with congruent triangles is their corresponding parts as we get deeper into learning about congruent triangles. And the important fact here is that corresponding parts of congruent triangles have to be congruent. They have parts that match up. And this is because they're exact copies of each other, right? So let's say these two triangles are congruent. So I know that they're exact copies. Then I know all their parts have to match up to each other. And we can see that we have some parts already labeled. So like this 7 side is corresponding to this 7 side. So we would call those corresponding sides, and they're congruent because they're the same length. We also have this 3 side, and that corresponds to this 3 side, and they're the same length, or they're congruent. Then we have the 3rd side. So this 3rd side, it has to correspond to this side because that's the only side that's left, and they're congruent, so they have to be the same length. So that means that I know that the green side of this second triangle has to have length 5.4 because this triangle is an exact copy of the first triangle. So we've got 3 sets of corresponding sides, pink, yellow, and green, and they're always the same length. And then we also have sets of corresponding angles. So let's look at our corresponding angles. We have a 23, and that's between our pink and green side. So that means that this angle here is the, whoops, not 24, yikes, is the corresponding angle. It's in the same position within the triangle as the blue angle in the first triangle. And my cat just knocked over a plant. Because they're corresponding, they have to be the same measures. So 23 and 23. Okay, we also have 112. So that's going to have a corresponding angle, and it's between the green and the yellow side. So its corresponding angle is right here, and they're congruent, so they're the same measure. So I know that angle has to be 112. And then finally, we have the 45-degree angle. That's our remaining angle, so it has to correspond to this one, and they're congruent, so they're the same measure. So this one has to be 45 as well. So we find that each triangle is an exact copy of the other. Okay, so that's a big deal, being able to fill in corresponding parts if we know the triangles are congruent, or being able to match up parts that would have to be corresponding. All right, last thing for kind of the intro is that when we name congruent triangles or write down in symbols that they're congruent to each other, it's really important that we pay attention to the order of the vertices or the corners. They have to be, corresponding vertices have to be in the same order. So let's say we make B pink, and that's a one swoop angle, which corresponds to angle Q, also one swoop, so Q will also be pink. We're just matching up corresponding vertices. We'll make A yellow, that's a two swoop angle, so on this triangle, the two swoop is R, so we'll have those match up. And then angle C and angle P are the three swoops, so those will be corresponding vertices. And they'll be green. Okay, so let's say I wanted to write in symbols that these two triangles are congruent to each other. I could go, let's say I go B, A, C. So there's a symbol for triangle BAC. And now I want to say that it's congruent to the other triangle. I need to list the vertices in the same order. So I went pink, yellow, green. So on this triangle, I also need to go pink, yellow, green. So I'd go Q, R, P. So I'm listing the corresponding vertices in the same order. We don't have to go in that particular order, like maybe I go C, A, B. That's fine as long as when I name the next triangle, I go in the same order. So now I need to go green, yellow, pink, so I would go P, R, Q. Uh-oh. Okay, so those are both correct. It would not be correct if I had them out of order. So let's say I do BAC, and then I tried to say that it was congruent to triangle RQP. These are out of order, right? The first one goes pink, yellow, green. The second one goes yellow, pink, green. So those aren't in the same, the corresponding vertices aren't in the same order. So this is not correct. We can't write this. This is not true. All right. So that's a basic intro of congruent triangles, what it means, their corresponding parts, and how we write the symbols.